Today we are going to talk about differentiation using first principles. So I hope you have watched the video on differentiation which I used to explain you. For example, I'll just recap on that knowledge first of all. So if you take an equation where y is equal to x squared, and if I ask you to get the differential of it, dy over dx is equal to, you multiply the power by the front number. There's 1 here. So 2x to the power 1. So differentiation is 2x. So this was so easy, right? Okay. You have to prove this. If you differentiate this term, you get 2x using first principles. Okay. Can you see I have written an equation here? Limits of h going to 0. So first principles equation is f dash x is equal to limits of h goes to 0 fx plus h minus fx divided by h. So this is the general equation for the differentiation using first principles. Alright, let's get a term. So you know that y is equal to x squared. I need to prove it using first principles. So I can take this as fx is equal to x squared. So f dash x is equal to limits of h goes to 0 fx plus h. What is fx plus h? Minus fx over h. So if I get the fx x plus h, that means I'm gonna put x plus h in here. So if I put anything here, you know that this becomes x plus h is equal to x plus h squared. Alright, let me put these terms. So I'm gonna put this term right here and this term right here. So limits of h goes to 0 x plus h squared minus x squared divided by h. So this is the differential. So let's continue expanding these terms. X squared plus 2xh plus h squared minus x squared. So what I did here is I just expanded this bracket. If you don't know how to expand, it's like this. You write two brackets here, expand this x squared, this into this plus xh, this into this plus xh plus h squared. So x squared plus 2hx plus h squared. Okay. Minus this term, I wrote it as it is, divided by h. So you can see this term and this term gets cancelled off. Then from here we can take the h out, which is 2x plus h over h. Limits of h goes to 0. So h and h get cancelled off. So f dash x is equal to limits of h goes to 0, you get 2x plus h. So when the limits of h goes to 0, what is f dash x? Is equal to 2x. Did you understand? So this entire thing needs to be showed using first principles to prove that differential of x squared is equal to 2x. Alright. So let's get another example. Let's take an equation where y is equal to 2x plus 1. 2x squared plus 1. So you know that fx is equal to 2x squared plus 1. So what is f? X plus h. It's easy if you do it initially itself. 2 bracket x plus h squared plus 1. Alright, let's get the equation of the first principles. F dash x is equal to limits of h goes to 0 fx plus h minus fx divided by h. So I'm going to put these values which I wrote initially. What's this value? That's going to be this term. So let's put it here. 2 bracket x plus h squared plus 1 minus, so what is fx? X squared 2x squared plus 1. So put a bracket, because if not you will make a mistake. Alright, next you need to simplify off. So if I write this, I write like the previous time. First the expansion of this term, that was x squared plus 2hx plus h squared. So I'm gonna take that entire term right in front inside the bracket. X squared plus 2hx plus h squared and plus 1 minus, expand it, minus 2x squared minus 1 divided by h. So let's expand this term to 2x squared plus 4hx plus 2x squared plus 1 minus 2x squared minus 1 divided by h. So can you see this term and this term gets cancelled? X squared, 2x squared and 2x squared gets cancelled, and you remain with these two. So in here you can take the h out. So like the previous way, 4x plus 2h divided by h. So h and h get cancelled. So now I wrote it twice. F dash x is equal to this. Now when the x goes to 0, what happens? This entire thing 2 times 0, right? So 4 times x plus 2 times 0. So this becomes 0 actually. So it becomes 4x. When the limit of h goes to 0, f dash x is equal to 4x. So you know the normal method. If you differentiate this easily, you know that dy over dx is equal to 4x, right? Number terms don't come because x is 0 here. So this you need to prove using first principles using this method. Okay, so I hope you understood. So you need to, let's recap again back into the first principle equation, differentiation using first principles. If you have an equation fx is equal to x, all right, then f dash x is equal to fx plus h. All right, let's create it. Limits of h goes to 0, fx plus h minus fx divided by h. So if I take this equation, you know that fx plus h is what? It's going to be x plus h. All right, so if I need the differentiation of this, you know straight away if you differentiate it, it's 1. X differential is 1. So if I differentiate using first principles, you know that the limits of h goes to 0, fx plus h, I found it right here. You can put this term here. So that is x plus h minus fx is x divided by h. So x and x get cancelled. H over h is 1. So if the limits of h goes to 0, what do you get? F dash h is equal to still 1. Did you understand? So the general equation is f dash x is equal to limits of h goes to 0, fx plus h minus fx over h. So this is the equation for proving differential using first principles. Okay, I hope you understood. Thank you.